Hi guys, so I've decided to record a video on this triangle method coming from the trigonometry because of course this kind of questions are very rarely asked. If I remember that the last time this question was asked was in 2014, so it's more than a decade now. So yeah, this kind of questions are not often asked, but you should be aware about this kind of technique at least, even though they are not asking you in the past papers or in your final examinations. As a mathematics student, you should be aware about this kind of tactics because it's really very helpful. So I'm recording this video over here, and you can utilize this whenever you feel like you need a revision on this kind of questions. So first of all, let me explain what kind of questions you should be aware about. And based on that, I'll also tell you what kind of solution process you need to follow using the triangle method. Of course, there are multiple ways to solve this question, but I am sticking with the triangle method because this is my favorite method. So the type of question that you should be aware about is they'll give you some kind of an angle that could be either acute, obtuse, or reflex. And then they'll give you some kind of a trigonometric ratio like sine theta, cos theta, or tan theta is equal to something in terms of k or some kind of a constant. So you can see that this is the first example where your given theta is an obtuse angle and the sine theta is equals to k. So this kind of an idea is given to you to understand whether the sine theta is a positive or a negative quantity. So in the obtuse, because we know that 90 to 180 is your obtuse angle, in second quadrant sine is positive, we know that. So by default, we can understand from this statement that k is a positive value or your sine theta is a positive quantity. So in the second quadrant, by default, if sine is positive, your cosine and tangent will be negative. So cos theta and the tan theta will be negative. So that is what we get an idea just from this single line of explanation. I'll give you another example also. This is the second question where the angle given to us is a reflex angle. Reflex angle is anywhere in between 180 to 360. So this two quadrants, your cosine and the tangent, this is your tangent quadrant, your third quadrant, and your fourth quadrant belongs to your cosine. So in both these cases, you can say that it's a reflex angle. But now they have mentioned that the cos theta is equals to k, and k is in between 0 to 1. So as k is positive values, of course, between 0 to 1, it is all positive. So your cosine is positive. And of course, now that you're aware about that the cosine is positive, you're in the fourth quadrant. So in the fourth quadrant, what happens? Of course, tan and sine is negative. So this kind of an hint will always be given to you in the question. And when this kind of hints are given to you, and then they ask you to find the expression for the sine theta, tan theta, or whatever is the unknown, in these cases, you are supposed to use this kind of a triangle method that I'm about to show you. Okay. As I mentioned that there are multiple ways through which you can solve this particular question. You can use your identities also. But yeah, in particular, I am really a big fan of a triangle method because it's not just helpful for this kind of cases, even in different kind of cases as you grow up, as you go into your university, or even if you're dealing with your mechanics, this kind of techniques are really going to be helpful, even in your, let's say, AS or A2 if you are taking mechanics. Okay, so what kind of technique I am talking about? See, first of all, we got the idea that sine theta is equals to k. I am first talking about the this question, okay, and then I'll also discuss the second question. First, let's stick to the first question. So we are aware about that the theta is an obtuse angle and the sine is positive. We are now supposed to find in terms of k what is cos theta, tan theta. I'll talk about sine 180 plus theta in a while, but let's first focus on the cos theta and the tan theta. So in this case, what I do is I directly draw a triangle like this, okay? Where of course it's a 90-degree triangle because I need to apply SOHCAHTOA to a, and one angle out of the two will be theta. If one is theta, of course the other one is 90 minus theta. It's up to you. You can mark it randomly. Okay, you can just draw a triangle and you can mark, let's say, the bottom one as theta, and of course the above one will be 90 minus theta if this is theta because this is 90 degrees. Okay, so let's say we are done marking this kind of a triangle. Now, given that sine theta is equals to k, I can write k as k divided by 1 also because of course 1 is not something that we are supposed to write. We can easily see that k is k without dividing it by 1. So yeah, in this case, if I'm supposed to mark my, let's say, triangle, sine theta is opposite over hypotenuse. So my opposite is k and hypotenuse is 1. So k and 1 comes over here because of that. That is exactly what I have done over here if you can see in my pink triangle. And after that, you can use your Pythagoras to find your third side. So over here, it would be 1 square minus k square. So 1 minus k square is what you can write over here. And that is exactly what you can see over here as well, right? So now that you're aware about this kind of a triangle, it's very easier for you to find what is equal to cos theta and the tan theta again using the SOHCAHTOA. So let's say if I want to find my cos theta, so my cos theta is what? Adjacent over hypotenuse. So this is my adjacent and this is my hypotenuse. But please note that you have to remember that you are in your second quadrant, okay? You are in your second quadrant. Only sign is positive. So whatever you will be getting over here, you will just have to add a negative sign to it. And that is what I have done over here, that my cos theta will be equal to this value over 1. Of course, I don't have to show divided by 1. It's not required. And then I'm just going to say that it's a negative because I am in a second quadrant. Same thing is implemented for the tan theta also. Tan theta is equals to opposite over adjacent. So k over square root of 1 minus k square. And of course, even this is negative because you're in the second quadrant. So that was about the first two trigonometric ratios. I'll come to this a bit later. Now let me move on to the second question so that you are able to grasp this concept that yeah, we can implement this triangle method whenever you get a scenario like this. So now you are having a reflex angle and the cos theta is given to you as a positive value. So you are in the fourth quadrant. Now in the fourth quadrant, you are supposed to find sine theta and the tan theta. You can implement exactly the same technique. You can draw a right angle triangle and then you can assume that this is your theta. And because your cos theta is given as k, cos theta is adjacent over hypotenuse. So adjacent is k, hypotenuse is 1. That is how you get cos theta is equals to k over 1. In that case, this will become now 1 minus k square. Now after this, if I have to find what is my sine theta is of course opposite over hypotenuse. So square root of 1 minus k square. But now with a negative sign because in the fourth quadrant, sine is negative. And if I can show you my solution, you can see that is exactly what I have done over here. And similarly for the tan theta is opposite over adjacent. So square root of 1 minus k square divided by k with a negative sign. As you can see, our answer is correct. Okay, so that is the kind of logic. I hope that the triangle method is now clear to you. Now, apart from this, there could be a third kind of a question or maybe a different kind of question that is very related to the triangle method. Okay, so in the first case, they've asked you what is your sine of 180 plus theta is equal to. So in that case, what you can do? See, currently you are in your second quadrant and this is your theta. Okay, this theta could be literally anywhere from this line to this line, right? It could be anywhere in between that. But let's say we are somewhere over here. So to this theta, if we add one more 80 degrees, okay, 180 degrees more to this theta, what's going to happen? We are now going to be in the fourth quadrant. And of course, the line is 180 degrees away. So this angle and this angle are exactly the same. So this theta is not changing at all. Okay, this theta is not changing at all, which means that your y and the x are exactly the same. Or in other words, your opposite and the adjacents are exactly the same. And even your hypotenuse is 1. There is no changes to the triangle. It's just that now your sine theta is going to be a negative value because now you are in the fourth quadrant and you are looking for a sine value. So sine value will be negative because there is no changes in the triangle. You can say that your sine theta will be equal to k, but now with a negative sign. And that is what I have shown over here. Sine of 180 plus theta is equals to sine theta only. Why it is equal to sine theta? Because there is no change in the triangle. So whatever is your sine theta will be the same output, but now you are in the fourth quadrant. That is why you are having a negative sign. So I hope this is clear. Now moving on to the second question. Over here, the third part, or you can say the second subpart, is explain why the sine 2 theta is a negative value for a 0 to 1, like your k is in between 0 to 1. In that case, you have to explain why sine 2 theta will be a negative value. See, first thing you will have to understand is your sine is only negative in your third quadrant and the fourth quadrant. Now that we are aware about that your reflex angle was in your fourth quadrant. What is your fourth quadrant? Your fourth quadrant is basically in between 270 and 360. Okay. So all the angles that are in between 270 and 360, anything in between that, basically your fourth quadrant is belonging to your this particular theta given in this question. So now that we are aware about this theta, it can lie in between 271, let's say, to 359, something like this, right? 271 to 359, you can say. So if I multiply this range by 2, let's see what do we get. If I multiply anything from 271 or maybe 270.5 to 359.5, something like that, very close to the very end points. And then if I multiply it by 2, let's see what is the 2 theta value that I'm going to get. In that case, let me open my calculator. So let's say 270.5 into 2, it is 541. And then if I take 359.5 into 2, it is 719. Okay. So now what have I done? For one complete circle, of course, we are aware about that there are 360 degrees. And in the ASTC diagram, we start with 0. And then all the angles that we mark on the axis are 90 degrees apart. So from after 0 it was 90, after 90 it is 180, after 180 it is 270, after 270 it is 360. Now after 360, if you want to go for the second circle, you will keep on adding 90, 90, 90. So 360 plus 90 is 450, plus 90 is 540, plus 90 is 630, and plus 90 is 720. Now we had seen that if you had multiply your 270.5 into 2, you got a value like 541. So now you are in the third quadrant. And then when you multiplied 359.5 into 2, you got 719, which means you are over here in the fourth quadrant. So if you are going to take any angle in between 270 and 360, and if you will multiply it by 2, by default you will be in the either third quadrant or you will be in the fourth quadrant. And regardless of that, because sine is negative in the third and the fourth quadrant, you are explaining that because of this reason, because if I multiply my theta by 2, my angle will be either in the third or the fourth quadrant. And because of that, my sine 2 theta will be negative if the k value is in between 0 to 1. Okay, once again, I'm repeating for you. For this question specifically, they had told us that the k value is positive. So cos is positive only in between 270 degrees and 360 degrees. That is the fourth quadrant. Okay, I'm talking about the first circle. Okay, in first circle between 270 to 360 degrees, or in short fourth quadrant, your cos is positive. So if your theta is in fourth quadrant, and now in the question they were asking you to find what happens when the theta becomes 2 theta, and specifically what happens to sine 2 theta. So first I take my fourth quadrant values 270 and 360 and multiplied by 2. And I realize that if I multiply this range of thetas into 2, I'll get the values between 540 and 360, which means it's in the third quadrant. So in the third quadrant, because sine is negative, that is the reason why sine 2 theta will be negative if k is in between 0 to 1 for this particular question. Okay. And that is exactly what I have written over here as well. Okay, I've taken one example, and through the example I have explained that your 2 theta will always be in between third and the fourth quadrant, hence your sine 2 theta. If your k value was equal to like in between 0 to 1, your sine 2 theta will be negative. I hope that this has given you some kind of an idea of how to solve this. And if you want some more example questions, I have given the questions in the link that I'll provide as a part of the comment or maybe the description of this video. You can access through that. And I've also attached the marking scheme for the same thing. You can compare your answers and feel happy that yes, you have understood how to use a triangle method. And on top of that, this last question or the last part is always up to like, your understanding about trigonometry overall. Okay, so I hope this has helped you. Thank you so much.